Friends, let's balance another one net ionic equation. This equation is for the reaction between hydrazine and chlorate to form nitric oxide and chloride. This equation we can balance by oxidation number method. First of all, we can assign the oxidation number for all the atoms present in the equation. Hydrogen, its oxidation number, that is +1. Oxygen, its oxidation number, -2. Here also it is -2. This chlorine in chloride, its oxidation number, -1. Now nitrogen in hydrazine, we need to find the oxidation number, that is 2x is equal to +4. Sorry, 2x, yes, just a second. 2x +4 is equal to 0. The sum of the oxidation numbers of a neutral compound is equal to 0. So 2x is equal to -4. So as a result, x is equal to -2. So nitrogen oxidation number in hydrazine, it is -2. The next one, chlorine in chlorate, we need to find chlorine in chlorate. Chlorine we can assume as X. Then oxygen, 3 times are there, 3 times -2, that is -6, equal to 0. That is X is equal to +6. So oxidation number of chlorine in chlorate, sorry, this reaction, this oxidation number, this is a polyatomic ion. Therefore, the sum of the oxidation numbers will be equal to its charge. Its charge is -1. So as a result, x is equal to 6 minus 1. That's equal to +5. So oxidation number of chlorine in chlorate is +5. The next one, we can calculate the oxidation number for nitrogen in nitric oxide. Nitric oxygen has oxidation number -2, only one oxygen atom and one nitrogen atom. Therefore, if oxidation number of nitrogen will be +2, it will be +2, +2. Now we have assigned the oxidation numbers of the atoms, especially nitrogen as well as chlorine. Now we can check the decrease in oxidation number and increase in oxidation numbers of these atoms, that is nitrogen and chlorine. Nitrogen, the oxidation number changes from -2. From -2, it changes to, what is that? +2. From -2, it changes to +2. Chlorine, its oxidation number changes from +5 to -1. That is, in nitrogen, the oxidation number, the oxidation number increases. Oxidation number increases by how many times? How to find that? The greater number minus smaller number. So +2 minus of -2. So it will be 2 plus 2, that is equal to plus 4. In chlorine, the oxidation number changes from plus 5 to minus 1. Therefore, here decrease in oxidation number takes place. Decrease in oxidation number, that is reduction. So how many times the oxidation number decreases here? Greater number minus smaller number. So plus 5 minus minus 1. Therefore, plus 5 plus 1, that is equal to plus 6. When we check the increase in oxidation number and decrease in oxidation number, they are the multiples of 2. So further we can simplify. This becomes 2 times, this becomes 3 times. So using this 3, we need to multiply nitrogen on the right hand side of the equation. Using this 2, we need to multiply this chlorine on the right hand side. So chlorine has to be multiplied by 2 times. 2 times chlorine. Then this nitrogen on the left hand side, sorry, right hand side, it has to be multiplied by 3 times. The opposite side we need to do that. So 3 times nitrogen. 3 times nitrogen. Now we can balance the left hand side. Right hand side 2 chlorine. Therefore, this chlorate also has to be multiplied by 2 times. So the coefficient 2 we can place it here. Nitrogen, the right hand side 3 times. So left hand side also it must be 3 times. But the left hand side nitrogen is present as 2 times already. Therefore, the left hand side what we need to do, we need to mention a fraction that is 3 by 2. So this hydrogen has to be multiplied by the coefficient 3 by 2. Now when we check the oxygen atoms on the left hand side, in chlorate 2 3s are 6. 6 oxygen atoms are present on the left hand side. But the right hand side, only 3 oxygen atoms alone are present. Therefore, in order to make the oxygen atom equal, we need to add 3 moles of water on the right hand side. 3 moles of water are added on the right hand side. Now we can check the charges on both the sides of the equation. The charges we can find now. Charges. Hydrogen, it's a neutral compound, therefore there's no charge. The next, chlorate, minus 2, 2 charges, the 2 negative charge. Right hand side, nitric oxide, neutral compound, therefore no charge. Chloride, 2 negative charge, minus 2. When we check that, both the sides, the number of charges are minus 2. Minus 2. The charges are minus 2 on both the sides. So there is no need of adding any hydrogen ions on the left hand side or the right appropriate side. This reaction, hydrogen ion or hydroxide ion, but this reaction takes place in basic medium. This is in basic medium, this reaction takes place. So if the charges are not equal, what has to be done? Hydroxide ions need to be added on the appropriate side. But here the charges are already equal. Therefore, there is no need of adding hydroxide ions on the any other side. Now we can check what is that. The mole ratio hydrazine mole ratio is in fraction. As per the rule, the mole ratio must be the whole number. So in order to make this whole number, the fraction into whole number, the whole equation needs to be multiplied by the whole equation needs to be multiplied by 2 times by the denominator of that fraction. So when we multiply, what will be that? The next page I am writing the answer. 2 moles, when we multiply 3 by 2 by 2, it will become 3 times hydrazine. It will become 3 times hydrazine, that I am writing here. 3 moles of hydrazine, 3N2H4. 3N2H4. The next 2 moles of chlorate will become 4 moles of chlorate plus 4 moles of chlorate, ClO3 minus, gives the right hand side 3 moles of nitric oxide multiplied by 2. So this becomes 3 times 2, 6. 6 moles of nitric oxide. 6 moles of nitric oxide plus 4 moles of chloride. 4 moles of chloride plus 6 moles of water. 6 moles of water. 3 moles of hydrazine reacts with 4 moles of chlorate ion. As a result, 6 moles of nitric oxide, 4 moles of chloride ion, and 6 moles of water are obtained as a product. Now the equation is balanced. Thank you so much for watching.